morning, a very good morning to one and all present here. Myself, Harsh Soni, and this session would be moderated by me. So, dear authors and invited guests, welcome to Technical Session 7G. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the fourth World Conference on Information Systems for Business Management, ISBM 2025, Bangkok, Thailand. The fourth edition of the conference is being organized in a hybrid mode. The physical event was held on 24th of September 2025 in Bangkok, Thailand. And the virtual event is being held through Zoom yesterday and today. That means 25th and 26th of September 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. So in this session, we have 10 presentations and each presenter will be given 10 minutes for the presentation and 2 minutes for the question and answers. On 9 minutes, I will raise a gentle reminder so that you can conclude your presentation and given duration. There's one another request to all the participants that you may all please stay connected with us till the closing remarks so we can give you the publication update. Further, if you have any query or any update, you can directly write it to me in the chat box. I'll be happy to assist you for that. Just before we start the session, I'd like to introduce you all to the chair for the session, Dr. Hemlata Vivek Gaikwad. Dr. Hemlata is an associate professor at Symbiosis Institute of Management Studies, Symbiosis International Deemed University, India. Her academic and research interests focus on leadership development, diversity and inclusion, behavioral science, and change management. Welcome, ma'am. Ma'am, is there any opening remarks for the participants?
Yeah. Very good morning to the organizers and the participants. And I think this is a chance where you can present your papers and the research which you have been doing. And I'm thankful to ISBM organizers who have given this opportunity so that I can even listen to the various research findings and the research areas which all of you are presenting. And it will be great interacting with you. And as Harsh has said, that we should keep ourselves confined to 10 minutes in the presentations. And I think if you will focus on your objectives, research design and findings, and any recommendations, if you have any, that will utilize the time properly. So I think we can start now, and all the best to all the participants.
Thank you, ma'am. Thank you very much. Before wasting our time, I'll just announce the first presenter name. First presenter is John Jang, and he's going to present the paper title AARA, an AI Registration Assistant.
Okay.
Dear presenter, you
Good
may please
morning.
proceed. Good
Yeah.
morning.
Good morning,
Hello,
everybody.
everybody hear me?
Yeah. Can you hear me?
Yes, we can hear you.
Okay.
Your screen is also visible. You may please proceed.
All right. So today's presentation, I'm going to present the registration assistant. So in this okay, so this is my outline for for this presentation. I'll give a very quick introduction, and then I'll talk about the agent workflow, and then see the experiment result. After that, then I will talk about the remark and the future possible improvement. This is large language model is used to process the front end. The reason that we use that is because nowadays a large language model is very useful and very friendly, but it's very big. It has billions or even hundreds of billions of parameters connection. There is a neural network, but it's a pre-trained. So usually speaking that you can think that a large language model is a function. You have an input, you get the output. But sometimes it may not be the things that which is you want the result. Some even you might have a so-called delusion or hallucination that things occur, and therefore people try to improve the performance by using the fine-tune, the IAG, which is stand for retrieval augmented generation, or prompt engineering and context engineering. The fine-tune actually means that you change the model. But this one usually is very expensive because it's a hundred billions of connections, so you have to go through. So they might have a different more method, which is to reduce that. The idea is to modify the weight by actually that are using a supervised learning to change, kind of enhance that, so that you can have a better result when you use that. When you have a domain knowledge, which is kind of to train or to fine tune this model. And the IAGX is a change in the knowledge source, in a sense, is something like that. That means that you actually give a better information, so that they can do better, because that now you have focus. And then the prompt engineering actually is to change the instruction. You create, usually speaking, that when we use this large language model, we have created better prompts. If you actually did like 2, 3 years ago, people were actually doing a research saying if you give a large language model certain keywords or something like that, and then they might give you a better result. That is very interesting. Of course, that nowadays that people not just want to have a better result, but you like to get the actual, the one which is a correct result. The performance guaranteed, but it's also accurate. And so this one actually we don't change the model, but we give a smart phrasing, in a sense that you give a good instruction, give a clear instruction and indicate that what do I want clearly. And context actually is very similar to prompt engineering, but because the agentic trend. And so actually they changed the input structure, designed that how information should be fed into the model, including retrieve document or user history and the task-specific scaffoldings and so on. This one actually gives us some idea about how do we improve the generative outcome. Fine tune is, you see that change the model, and then this external, and then this instruction to the model, and then the input structure, in a sense, is a kind of redesigned to give a better work space, and so work together. And then actually that we use ChatGPT 4 and also ChatGPT 3.5 Turbo in our case. And this is the system design. In this system, we give system actually give a prompt. It's kind of misleading because actually here is we're talking about this program actually give a prompt, but usually the system prompt that are used in large language model means that you actually that you kind of define the rule for that particular model, and then tell the large language model saying that what is your role and what I'm expecting you to return and so on. All right, but assuming that this one is from the system's output and as the user giving input, and then the user actually then will give the input, and to large language model is very good at to process to understand the natural language, and therefore that when you give a natural language input, and then also that we give a very clear instruction, we try to direct and send that, okay, what should you return and so on, so they will try to do that for us. And then after that, you get this information, and then we feed this into agent, and then it will generate the output. In this in this in this project, actually, that we said this registration schedule scheduler assistant. And so we define the role for this large language model, saying that, okay, you are an assistant and you are doing registration scheduling. And then I'm require you to return a Python dictionary. Now this is JSON. Actually, Python dictionary is a JSON, right? It's a JavaScript object notations object. And so then we expect that. And then this actually is a return stuff. The first one, you have a key courses, and then the other one actually is availability. And then and we give an example. We also give an example such as, so this is actually is a one shot, few shot. You can, of course, you can give few shot example, but this is, we only give a one example in here and saying that, okay, so the output should be like this. And actually that we also say that, okay, do not explain. And the reason is because that we had to pay, right? For open, using the open AI API, because they based on the token, input token and output token to charge you, right? And so this actually that we create a client for OpenAI. We use GPT-4, as we say. We also use GPT 2.5 Turbo. So use this model, and then this message. Here the system part actually that we use it in previous two slides. We use that to define the rule and also give a very clear instruction saying that, okay, what kind of stuff we should return. Now in our case, actually return a Python dictionary. And then also the other one is a user's actual input. So this one is the one which is in the diagram, one which is we say that the user's input. And then after that, we do evaluation and then get the result. And then this one is just in case if you don't want to evaluate, and then because the security concern, so you can use the ASTD to event. And then this one is an agent workflow, and you can see that we have a lot of filter and the conflict resolver, and then eventually that we give the output. The load actually load the data from the file system, and then this file actually is we store this in Excel file
Sorry to
and
interrupt you, dear
convert this
author,
one
but
in.
this is a 1 minute reminder.
Okay, okay. So and then this is the filter, which is a filter out to make sure we only have a very section, and the conflict resolver actually try to make sure no two classes actually conflict. And then this is some of the output. For example, we give a natural language input, say I'm free for something, I'm available, and then even in here you can see that we have space and not space. And not only that, we can say, okay, I like to do something in the afternoon. Then actually that I can process very well. And in addition to that, sometimes it's not feasible, and maybe you don't get a very close call because that is not in the system, and or sometimes that you have more, right? So this is a conclusion. We successfully input that and using large language model on top, so it become very friendly to understand the natural language. We actually use this for GPT-4 and GPT 2.5 Turbo. So this one actually is very good. We can map this system to other business scheduling application. Others such as Amazon and so on, they track and so on and so forth, right? And so this is a possible improvement. For example, in our school, actually we have a wait list, so students actually can register on the wait list rather than see, oh, this one, if they're not available, and then you can use others. Sometimes the student might want to use that. The other improvement is a graphic user interface, or maybe use a section taken, and to make this useful. And the other one is the voice interface to make sure that for visual impaired user, actually we can help them. If you have any security or privacy concern, maybe you can keep your system locally to run it locally, such as using, for example, that we also have some experiment using Olama server, and so that you can use open source stuff, open source model, so you can download. But GPT-4, I don't believe that is you can download because they are not open source. But others actually they are open source, like Llama 2, Llama 3, those model or Mistral, those models that you can download. So you can then run on your own computer, but usually it's a very big. Okay, it's a giga, and so and besides, if you don't have GPU, may not be very easy to do that. All right, thank you. Any question or comment?
Hello.
Thank you.
Yeah, Doctor, very nice research and presentation which you did. The thing
Thank
which
you.
I wanted to ask is, have you implemented this in your university?
No, because the reason is because most of the system right now they do have a dual authentication. Now in our system that we are doing authentication, so that means that unless that the school allow me to do it, but I don't think so because the privacy issue. Now you see that in the United States, usually the students the privacy, so we can. I don't think that we can do that, but of course, that if just for our school, because we are we are in school computing, so maybe, but I didn't ask, so I don't know.
Okay. And then in that case, how have you validated your the scheduling model which you have prepared? Have you validated it somewhere?
Actually, that we just simply just run some cases and they see, oh, it looks fine. Actually, it's not really that I do the beta test. No, I don't think so. Yeah, sorry.
Yeah, because unless and until you validate and do the pilot study on this, that whether scheduling is happening properly as per your the plan which you have done, maybe there could be some lacunas which you will have to take care of.
Yes, yes. Thank you for your comment.
Yeah, so I think you should do the validation that will make your model more effective without any flaws. And if you can take permission, maybe for a small class scheduling, if it can be done at your university, that will help.
That's right. Yeah, that's right.
Because
Thank you
until
for
then,
your
it
comment.
remains only theoretical, unless and until you actually implement the model.
Mhm.
Yeah. So I think that is my advice. So you can, if your university permits, you can work on it.
Thank you.
Thank you so much.
Thank you. Thank you, everybody.
Thank you, dear presenter, for this wonderful presentation. Now I'd like to invite the next presenter. Next, we have Antrong, and he's going to present the paper title Adapting Large Language Models for Customer Service, a comparative study of RAG, Raft, and Dora. Is the presenter is available?
Yeah. So we are here. So just wait for a moment.
Can you see my screen?
So you are going to present the paper title on behalf of the author, or?
Yes, so I'm here, but my student An Nguyen so will present this topic. Okay.
All right.
So go ahead, An.
Okay. Morning, everyone. On behalf of our group, I will present a paper entitled Adapting Large Language Models for Customer Service, a comparative study of RAG and Dora. Now I will walk you through our roadmap. First, we come to the introduction. And next, I will give you a short review of the key methods considered in the paper, RAG, and Dora. And next, we jump to the proposed framework for analysis, followed by the experimental result and analysis. Finally, we wrap up with the conclusion section, where we highlight the key takeaway and our future directions. Now, let us begin with the introduction. Nowadays, we must recognize the strong potential of the LLMs in automating customer services, but there are some challenges in deployment. First, we must ensure factual reliability. Second, we must balance computational efficiency and latency. And lastly, the model can adapt to evolving and complex queries. And there are some emerging solutions, RAG, and DORA, instead of the traditional fine-tuning with high retraining costs and risk of hallucination. The objective of this research is to conduct a comparative analysis of RAG, and DORA for customer service chatbot. We evaluate across three criteria: response accuracy, computational efficiency, and robustness to diverse queries. Now we give an overview of the background methods, RAG, and DORA. Firstly, I'll talk about the retrieval augmented generation. This method combines retrieval of external documents with generation from the LLMs, which help us reduce hallucination via crowded passages. But its limitation critically lie in the retrieval quality. Next, I will discuss the retrieval augmented fine-tuning. This is a method extending the idea of RAG, but it is a fine-tuning methodology. We train the model to cite evidence and ignore noises. And it is very useful for domain-specific support with Distractor. Now I'm talk about way decompose low-rank adaptation. This is the PEP method improving on LoRa, and its effectiveness lies in the fewer parameters, avoid forgetting, and lower latency. With that background in mind, now we jump to the proposed framework for assessment. This is the overall framework diagram of our research, and we get back to this later. We use the PyText customer support LM chatbot training for this paper. The dataset structure contains 5 columns: instruction, category, intent, response, and flag slot. We extracted 54 QA pairs covering all the intents in the dataset to create the evaluation set. We used the Quen 2.57 billion instruct to be our backbone language model. Now we come back to the diagram. You can see in the screen, in the first phase, we split the dataset into train data and test data. We use the train data in the training phase, and in the training phase for us, we will construct a two-stage index retrieval, and with DORA and RAG, we will create a fine-tuned model for them. The output of RAG is the sparse index combining with a dense index. With DORA and RAG, we set them the properly configuration. With RAG, apart from the configuration, we must create a chain of thought reasoning column to enhance the training. After that, we will come to the inference phase. Now we will use the test data for this phase. After generating all the answers from the test data, we will feed them into the evaluation phase. There are 2 types of metrics here. First, answer quality, including accuracy, relevance score, and coverage. And generative output quality, including blue, ROFL, and hallucination rate. Now is the time we examine how well they perform in the experimental result and analysis. In the result, we can see 2 tables. The first table is the result of answer quality metrics. And the table 2 is the generative output quality metric results. You can see in the first table, graph dominates most of the criteria: accuracy, relevance score, and coverage. But in terms of latency, DORA is the fastest, although all the three criteria, it is the lowest. In the table 2, you can see DORA has the highest score in blue and ROFL, the traditional NLP metrics. But RAP and RAP seems to be more confidential because they have low hallucination rate, and RAP have the lowest hallucination rate. We would like to draw some impact of data set size on DORA. With small data sets like the data set we use in this experiment with nearly 30,000 rows, the hallucination rate is fairly high. But with large data set, for example, squat, it achieves low hallucination and high traditional NLP metric score. Finally, we will wrap up our research with the conclusion. There are three comparative findings that we can conclude. Firstly, RAF has the best balance of routing accuracy and response relevance. RAF has strong factual routing, lower latency, and ideally with knowledge by access. And finally, DORA is highly data dependent and risk hallucination on small datasets. In our future work, we will combine DORA adapters and graph retrieval chain of thought to create a low overhead and robust routing method. And we also considered incorporating user rating signals to reduce hallucination and improve alignment with satisfaction. Thank you for your attention. That's all.
Thank you, dear presenter. Ma'am, do you have any question for this presentation?
Yes. I think the presentation, you compared the three models which are there for on services. So one thing like what I want to ask is, do you think when this DORA or RAG or RAFT which you have applied, though they are increasing the efficiency, so how are you thinking of the addressing the ethical bias which comes or ethical issues which comes on over reliance on these technologies?
Can you explain it in a more
Like,
comprehensive?
these LLMs can limit the human empathy or maybe marginalize certain groups because it is based on your training data. So,
Okay.
whatever training data is going in, how will you see that the impact of that training data is lesser on actual customer services?
I think in our current experiment, we only use the 7 billion model as our backbone, and there's some limitation on the roles of the dataset. However, the comparative trends remain qualitatively consistent because it's mainly concentrate on the difference in training methodology rather than the model size and the dataset itself.
Okay. And according to your research, which model is best?
I think graph retrieval augmented fine tuning is the best model. It's not the best model, but it's best balance between latency and precision.
Okay, and any weaknesses of this model which should be addressed?
Model, the only drawback of the model is in deployment it requires two stage. You must create a chain of thought reasoning column. It requires more GPU resource before you can do the training.
Fine, that's all from my side. Thank you.
Thank you.
Thank you, dear presenter, for this wonderful presentation. Now I'd like to invite the next presenter. Just a second, you have to, yeah. So next we have Tafizul Hassan Zihan, and he's going to present the paper title, An IoT-enabled real-time monitoring, altering, and cloud data management system for optimized water quality control in regulating aquaculture systems. Dear presenter, are you present here?
Yeah, hello.
Yes.
Assalamu alaikum. Am I audible?
Yes, you're also audible and the screen is also visible. You may please proceed.
So, good morning, everyone. I'm Tafizul Hassan Zihan from Independent University, Bangladesh. Today, I'm honored to present our joint work with Sher Bangla Agricultural University. This is our outline, which we'll go through shortly. This research focuses on building and field validating an affordable real-time IoT system for water quality monitoring, optimized for low-resource aquaculture farms in Bangladesh. We designed it to support daily operations, trigger instant alert, and manage long-term trend on a limited budget. Recirculating aquaculture system, or RAS, are promising solution for fish farming in water-scarce areas like Bangladesh. However, the environment inside the RAS tank is fragile. Fish survival and growth depend on real-time stability of multiple parameters like dissolved oxygen, pH, temperature, turbidity, ORP, conductivity, and total dissolved solids. Manual monitoring every few hours isn't enough, especially in low-income settings where response delays can lead to fish losses and system crashes. That's the core problem we are aimed to solve. Our goal was to build a robust system that monitors 7 key parameters, uploads them to cloud in at least 15 seconds, and instantly alerts to users if any threshold is crossed. But cost was the key. We had to keep it under $700. Also, the alert mechanism had to be usable in local context, so we used WhatsApp for notifications. Finally, we validated it through real deployment in operational tanks. Here is the architecture. All sensors are connected to a Key Studio 2560 Wi-Fi Plus, which is an Arduino Mega board with integrated ESP8266. This is powerful enough to process 7 sensors in parallel with the display also. Data is published via MQTT protocol to ThingSpeak, a cloud platform that handles live plotting, clouding, and alert conditions. We defined upper, lower bound for each parameters so that, as example, if DO drops below 5 milligram per liter, an immediate WhatsApp alert is pushed through a webhook to the user's phone using our web app. This is our cost breakdown. We used DF Robot gravity series sensors because they are reliable, waterproof, and available in Bangladesh. The Key Studio controller helped reduced complexity by combining two microcontrollers. Overall, we stayed within the 700 budget, making this viable for small commercial RAS farms. To ensure sensor accuracy, we calibrated using commercial reference solutions. For pH, we used 3-point buffer for pH 4, pH 7, and pH 10. For EC and TDS, we used KCI solution, and for ORP, a 220 millivolt solution. DO was calibrated by exposing it to air-saturated water, which gives a known DO value. Over months of testing, we observed minimal drift. Recalibration was only required once per month. We tested the system at Shere-Bangla Agricultural University's commercial-scale RAS tanks. The sensors were placed inside grow-out tanks containing tilapia. The system recorded 15-second interval data for 5 continuous months, resulting over 440,000 data points. This high temporal resolution gave us deep insight into real water dynamics. Our system constantly kept DO levels above 10 milligram per liter. The correlation between electric conductivity and total dissolved solid was strong, which validates chemical consistency. The inverse DO and temperature correlation was 0.82, a known aquatic physics pattern. Importantly, our alert responsible within 30 seconds of any violation, ensuring fast intervention. Here is what the data shows. We found clear dial patterns. Temperature rises with ambient heat during the day, and DO level falls due to decreased oxygen solubility. DO hits its lowest value in afternoon, sometimes under 6 milligram per liter. pH shows a light rise during the day due to photosynthesis in algae or biofilms, cooling down the dissolved carbon dioxide. This pattern repeatedly across days and seasons, giving confidence in both data and the system. Alerts drove faster invention and more confident routine management. We also captured events that signaled biofilter stress guidance maintenance. We worked on added we are working on adding actuation control to trigger PF buffers automatically. A predictive model for early warning is also in development. Finally, to support rural use, we plan to adapt this for solar powers and LoRa modules. Our key contribution include the first validated multi-sensor IoT system for RAS in Bangladesh, live cloud alerts, high volume data acquisition, and affordable bill of materials. It opens the door to smart aquaculture in lower and middle income countries. Wrapping up, we replaced slow manual water checks with an affordable always-on system that warns in real time. It feeds real farms, validated over months, 7 parameters, and reliable alert that drive action. Next, we scale across the site, adding predictive and closed control, so system doesn't just warn, it stabilizes the water quality automatically. Uh, thank I thank the FabLab IUB and Fisheries Department of Shere-Bangla Agriculture University and our team members who helped during the deployment and testing. Special thanks to Dr. Shahabuddin for tank access. Uh, thank you. I am happy to take your questions.
A very good study, Fizul. I hope I'm pronouncing your name correctly. I just
Yes, ma'am.
wanted to know that since you have made this system, how does your system ensure the reliability of sensor reading over time? Like since low cost sensors are there, they often drift when you are calibrating. So how do you ensure the reliability?
Yes, ma'am. Actually, we compared our sensor read with the commercial manual check system they have. I mean, the Sheribangla Agriculture University have. They use their commercial and very high cost manual check some sensors. I don't know their name, but yeah, we compared with them and ensured that our data is within the range. Actually.
Okay. And secondly, like how scalable is this architecture for large fish farms?
Um, it is scalable in sense of the development of our hardware, but in software part we used free cost free ThingSpeak and that type of IoT protocol. Here we have to do some research and develop some open source system. Uh, you see, the ThingSpeak is not open source right now. For now, this system is not open source, but we will develop it shortly.
Okay, so like currently in your architecture, the Arduino node, how many sensors is it handling right now? Whatever model.
Seven,
How
seven,
many?
seven sensors.
7 sensors. So can you enhance, maybe if you enhance that and maybe around more than 7 if it can handle. So do you think it will be scalable?
Yeah, for Arduino Mega, it can actually handle up to 12, uh, 12
Okay,
sensors. So yeah, it will-
fine. And for how much time have you implemented this? Like you said, you have already for months you have uh, checked it by implementation and you have taken the readings.
yes, ma'am. Yes, we implemented in last December, and since then it was running for about 4 months continuously. Then we took it to our lab and recalibrated and
Okay.
re
And
maintained.
what about commercialization? Have you thought of it?
It's still under prototyping, so maybe after one or two more prototype, we will thought about that.
Okay. Thank you.
Thank you, ma'am.
Thank you, Tafizul, for this presentation. Now I'd like to invite the next presentation. Next, we have Yosef for presenting the paper title, Citizens' Perception of AI Government Chatbot Adoption. Dear presenter, you may please proceed with your presentation.
Good morning, everyone, again, and thank you for attending this session today. My name is Dr. Yusuf Al-Arabiyat from Amman Arabiya University. We are pleased to present our study, Citizens' Perception of AI Government Chatbot Adoption. Here's today's agenda. I will start with an introduction and explain the research gap and objectives, present the theoretical framework, methodology, key results, and finally share recommendation and conclusion. As we know, today government are increasingly using AI chatbot to enhance electronic service. However, despite the potential adoption among citizens remain low. So our study explore why this is the cause, focusing especially on the Jordanian context. While many studies have examined AI in areas such as retail banking and healthcare, private sector, the citizen perspective on government chatbot remains unexplored. Our main research question is what are the key determination influencing citizen adoption of government chatbot? The objective of our study is to understand the drives and barriers of chatbot adoption from the citizen perspective and provide accountable insight for government and developers. According to theoretical framework, our study is guided by Rogers' diffusion of innovation theory, which includes five classical factors: low complexity, relative advantage, compatibility, triability, and observability. And to address the unique nature of AI chatbot, we extended the framework by adding four critical factors. As we see, chatbot responsiveness, perceived intelligence, anthropomorphism, and trust in chatbot. In our study, we adopt a quantitative approach by using an online survey. The data was collected from 385 Jordanian citizens who had interacted with government chatbot in the last 6 to 12 months. We analyzed the data by using descriptive statistic and Pearson correlation with SPSS. The descriptive analysis revolved generally low means across all constructs, with training between 2.08 and 2.85. This indicates skepticism and low willingness to adopt government chatbot. Among the lowest rated factor, we are perceived intelligence and responsiveness. This suggests that citizens do not find chatbot intelligence enough or responsive to their needs. Our findings show that responsive and received intelligence are strongest predictors of adoption. The citizens are more likely to adopt chatbots that are quick, accurate, and human-like. Reliability and relative advantage also play an important role, while trust and compatibility have moderate effect. According to the interrelationship, we also observed strong interrelationship. For example, intelligence chatbots are also seen as moderate responsive. And when chatbots appear intelligent, citizens recognize more benefit. Trust increased while chatbots responsive quickly and efficiently. Based on our results, we recommended government to firstly improve chatbot responsiveness, enhance intelligence with better natural language processing, ensure data security, offer pilot program, and add human-like features to increase engagement. Our study conclude show that low adoption is mainly due to concern over responsiveness, intelligence, and trust. By addressing these factors, government can increase citizen adoption and maximize the value of AI-driven service. Thank you very much for your attention, and now I will welcome to your question or feedback. Thank you.
Thank you, Dr. Yusuf.
Welcome.
Your study is quantitative in nature. And
Yes.
what I understood from your studies, you have studied the participants who were using the government chatbots for last 6 to 12 months.
Yeah.
Now, when you are taking their perspectives, so have you taken the perspectives of people or I think those citizens who were not using? Because that will be giving you more insights that why are we not using those who are using are facing problems. So as you took the theoretical base of diffusion of innovation, so diffusion of innovation is, as you know, is having that normal curve, and there are some people who will start using immediately and then it goes on. But what about the people who have not used? What are their problems or what are their perspective of not using? So is there a problem in the technology readiness? Are they not technology friendly?
Actually, my survey we didn't measure that, but in my survey we expect who that doesn't use chatbot. But in the future research, we will put this in the future research. Actually,
Okay. Okay.
because it's a good area. Thank you for your feedback.
And what kind of sampling method did you take, like when you selected these 358 participants?
It's a random sampling by email. We send it, but in the survey we put the question who use chat bot and who doesn't use at all. That doesn't use, we expect them.
Okay. So, through online sampling, could you actually identify the respondents who had these 6 to 12 years of usage of AI chatbots?
Not for 12 months, يعني, for from 6 to 12 months that use it, the last use of chatbot. But the main problem in the our government, it's there's no يعني, you have to must encourage you for using chatbot يعني, and adapt it.
All right. And when you did this, the people who were not having these experience, how you ensured that they are not filling the form?
I didn't get your point, sorry.
Like when you rolled out the online survey, it must have gone to all the people who may be using and may not be using. So, what control did you use to ensure that the people who do not have experience in these 6 to 12-month range are not responding to your survey?
Actually, I told you before, I will put this point in the future research, inshallah.
Okay, I think because if your research method is strong, your findings will be validated, and then you will be able to recommend this.
Because
So
I
you
concern that's about who using the chatbot actually in this study.
okay. So yeah, but still the research method has to be, you have to ensure the reliability of your method and your sampling criterias to get the proper results. So if you can work on that, I think you will get better results.
Sure. Thank you. Thank you. Thank you, Doctor. For your
Yeah, thank you so much.
You are welcome. Thank you.
Thank you, Yusuf, for this wonderful presentation. Now I'd like to invite the next presenter we have, Indra, and he's going to present the paper titled College Year Supervision as a Catalyst for Digital Transformation, Insights from a Rural Indonesian Secondary Schools. Indra, are you available in the meeting?
Yes, sir. Yes, sir. I'm
Yes,
here.
you may please proceed.
Okay. I will share my screen before I'm present. Wait. Okay, can you
Yes,
see
we can see
on?
your screen.
Okay. Wait, sir. Because my internet unstable in here. Okay. Can you show my screen, sir?
Yes, it is.
Okay. I will start it my present. Okay. Assalamualaikum warahmatullahi wabarakatuh. For this morning, I will present our paper with the title Collegial Supervision as a Catalyst for Digital Transformation. Okay, for the first, I'm Indra Lesmana. I'm from State University Malang, Indonesia. And the next, I will explain about background this research. Digital transformation in education is an inevitable necessity in the 21st century. The integration of information and communication technology in the learning process is not only a support, but also an integral part of creating adaptive, flexible, and contextual learning. So, in Indonesian, government has responded to this demand through various policy such as the Merdeka Belajar program and school digitalization. In a rural school face bigger challenge about that there is include limited limits technological infrastructure, unstable internet connection, low digital literacy among teachers, and minimal access to ongoing training and mentoring. So for the next about problem statement, for the first, inequality in digital learning implementation between urban and rural school. And number two, top-down supervision often ineffective for teacher real needs. And number three, need for a participatory and collaborative approach to teacher supervision. And the next about research aim. For the first, uh, our research can be described about to identify collaborative values in collegial supervision. And number two, to analyze challenge in the implementation. And number three, to explore stakeholder perception of collegial supervision in digital transformation. Okay, for the next about methodology, research design, we are choose descriptive qualitative and location at high school or SMA Diponegoro on Malang, East Java rural area, and any participant, principal, teacher, committee, and student, and data collection in this research about interview, observation, and documentation. And the next about data analyze with approach thematic analysis and any step, three step to get a result. For the first, transcription, coding, and grouping into times. And the three, triangulation for data validity. We use in-depth 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 interview and documentation and observation. So for the last member checking to confirm interpretation. So key findings for the first about collegial supervision, any trust and open because trust is key in building interaction between teachers because each individual feels safe and comfortable to share experience, convey challenge, and receive input from colleagues. But number two, equality and reciprocity. There is no role dominance between senior and junior teacher. Each teacher is positioned as an equal partner who can contribute and learn from each other. And number three, collaboration and joint reflection through regular forum, such as the School Subject Teacher Conference, MGMPS. Teachers have a permanent space to exchange experience, develop joint teaching material, and discuss learning strategies, include the use of digital technology. And number four, professional and constructive feedback. Input provided between teachers is constructive and oriented toward improvement, not toward to judgment or negative assessment. And the last about spirit of mutual cooperation. And the next, any challenge, time and schedule constraints. And number two, imbalance in teacher expertise per subject. Number three, misunderstanding of collegial supervision, and number four, limit digital infrastructure, and even digital literacy among teachers. And for the three about results, stakeholder perception. Number when it teacher can confident adopt new strategy, and number two, principal accelerate teacher adaptation to digital literacy, and number three, student more engaged in learning with digital tools, and number four, commit improve quality of teaching and learning. So in this case, collegial supervision integrate local cultural values with modern principle. Number two, can promote reflexive and collaborative teacher communities and can solve challenge highlight need for more adaptive and contextual support, align with global perspective on professional learning communities. Uh, and conclusion, collegial supervision enhance professional competency and digital innovation, with collaborative school culture in rural setting, sustainable approach for teacher capacity building, and limitation single case, short duration, and qualitative only. Implication and future research need for combine a qualitative and quantitative method. And number two, expand to diverse school context. And number three, longitudinal studies for deeper insight. And number four, focus on sustainable teacher professional development. So that's all about my presented. Thank you, sir.
Thank you, Indra. You have done qualitative research. So can
Yes,
you tell
ma'am.
how many participants were there from your the different categories, like how many teachers, how many students?
Okay, ma'am, I will answer that. Uh, any 5 teacher and 1 principal and any 5 committee. That's all my our response or informant from this research.
Okay, and how long did your interviews last? Did you take what kind of interview did you take? It was a structured interview or a unstructured, or what kind of interview you had planned?
Sorry, ma'am, can you repeat it? Because
Like
my internet
you
unstable
identify
in
the
here.
questions and ask the same questions to all the participants, like in teachers, if for one teacher whatever questions you asked, the same questions were repeated for all, or did your questions evolved through the discussions which you had with the participants?
Okay. For the question will develop about one informant to the next informant. We we up we analyze before we interview for the next informant, ma'am.
So that means it was a semi-structured interview. And next, like, how did you identify the themes? Which method you use? Like, you showed 2, 3 themes after analysis of the qualitative data which you took. So, how did you identify? Did you use any software?
Yes, ma'am.
Which software did you use?
Sorry. Can you repeat, ma'am?
When you took interviews, so your interview scripts which were there for analyzing those interviews, did you do it manually or you use a software?
Oh, okay. I doing manually, ma'am.
Okay. You did all the interviews analysis manually. Which method did you use to analyze? Was it inductive or was it deductive?
I use model Miles and Huberman, ma'am, because I I use inductive. Yes, inductive
Okay.
to deductive. Okay.
Yeah, so I think here also, since first your sample size is small, you took very few participants. So did you achieve, because you took only like one principal.
Yes.
So how did you achieve saturation? Because in qualitative research, achieving saturation is important to get good findings. Because maybe if you would have interviewed another principal, some more themes or some more data could have come, which would have been different from the first principal. So that is the crux of qualitative research, that when you are interviewing and you are doing analysis, you have to achieve saturation. If you're not achieving saturation, means your analysis is not complete. So I would suggest you that you take more interviews. You have given in future research, like you will be going for diverse school context. But I feel that you should have more participants so that you achieve saturation in coding and theme generation. And you said you did member checking. That is a good control which you have used, because qualitative research controlling and getting the reliable results are anyways very difficult, because subjectivity comes in. But to reduce the bias, your saturation must be achieved, which I think is not achieved, because with one principal and very few people who have taken very few teachers, and you have not mentioned also that you achieve saturation. I think if you increase more participants, your data will become rich, and then your themes will be more impactful.
Okay, ma'am. Thank you for suggest.
Yeah. Thank you.
Thank you, Indira, for your presentation. Now I'd like to invite the next presenter. Next, we have Nishat Sheikh, and she's going to present the paper titled Deep Learning in Oncology, a multimodality survey of diagnostic and prognostic models. Dear presenter,
Yes.
please proceed with your presentation.
So I guess my slides are visible and I'm audible as well.
Yes.
Okay, thank you. So good morning, everyone. I'm Nishat Sheikh, and today I'll be presenting our work titled Deep Learning in Oncology, a multimodality survey of diagnostic and prognostic models. This work has been carried out along with my co-authors, Parth Shah and Bimal Patel. The presentation is based on paper ID 794, and I'm grateful for this opportunity to present it here at the 4th World Conference on Information Systems for Business Management, ISBM 2025. Here is the outline of my talk. We will begin with the motivation behind this study, followed by research problem and objectives. I will then cover the different data modalities used in oncology and summarize recent advances in deep learning. After that, I will present the multimodal fusion models, key findings from our analysis, research gaps, and recommendations. Finally, I will share our future outlook and conclude the presentation. So, cancer remains a global challenge. It is one of the leading cause of mortality worldwide. Early detection and accurate prognosis play a crucial role in improving patient outcomes. But traditional approaches struggle with the heterogeneous nature of the data in oncology. For example, imaging, histopathology, and genomic data each provide data insights, different insights, yet integrating them effectively is difficult. So this is where AI revolution and specifically deep learning offer a powerful solution. With its ability to automatically extract features and perform multimodal integration, deep learning is transforming cancer diagnostic and prognosis. Despite the promise of deep learning, several gaps still exist. First, there is a limited, you can say, systematic analysis of multimodal approaches in oncology. Second, a unified framework for applying AI in cancer detection and prognosis is missing. And third, there are challenges in translating research findings into the clinical practices. To address these challenges, we conducted a study covering over 60 plus recent papers published between 2021 and 2025 across 4 major cancer types, that is lung, breast, skin, and brain, using 3 primary modalities: imaging, histopathology, and genomics. So our objectives were threefold. First objective is to conduct a systematic analysis of deep learning architecture. Second, to create a taxonomy of multimodal fusion strategies. And third, identify the gaps and barriers in clinical deployment. Oncology research today is driven by 3 core data modalities: First, medical imaging such as CT, MRI, PET, ultrasound, etc. So this captures partial and volumetric tumor information. Techniques like 3D CNNs are widely used here. Second, histopathology, which uses whole slide images to provide cellular level detail. Multi-scale feature extraction methods are key in this domain. And third, genomics, which examines molecule profiles, gene mutations, and expressions. Here, graph neural networks are particularly effective in modeling complex biological relationships. In our review, we analyzed several deep learning architectures. First, CNNs, often modified VGG16 or multi-scale CNNs, achieving very high accuracy, especially in lung and breast cancer studies. Second, RNNs and LSTMs. This is powerful for the sequential data processing. The third one is the transformers. This have shown superior performance due to their ability to model global context. Fourth, multi-model fusion models, which leveraging cross-attention mechanism for integrating heterogeneous data. And the last, attention mechanism. This is crucial for interpretability as they highlight clinically relevant features for the decision making. Here you can see a comparative summary of different deep learning models used in oncology. The key point is not just high accuracy, but also the trade-offs. For example, CNNs work very well with imaging data, but often lack interpretability, while transformers provide global context, but come with higher computational cost. So this table really highlights that no single model is perfect. Each has strengths and limitations. This table presents a set of diagnostic studies that apply deep learning. What's interesting is that across cancers like lung, breast, skin, and brain, we consistently see very high reported performance. But what matters is how well these models generalize beyond their dataset. So while accuracy is high, clinical readiness still lags behind. Here in table 3 prognostic deep learning models, we can see studies that focus on prognostic, which is predicting survival rates or treatment outcomes. So prognostic models are inherently more complex because they require long-term patient-specific data. So this table shows promising results, but again, there is a still gap between a performance on research data set and use in real-world hospitals. So in this figure, we summarize the key contribution of multimodal deep learning in oncology. The takeaway is clear. Combining imaging, histopathology, and genomics almost always leads to a stronger predictions than using a single modality. In other words, we can say we integrate different perspective of the disease. We move closer to personalized and precise cancer care. Our analysis lead to some interesting findings. Fusion strategies, so about 67% of the studies prefer late fusion for simplicity, while 33% used early fusion, often achieving better performance. Second, transformers and attention models consistently outperform CNNs, especially when dealing with heterogeneous data. Multimodal fusion significantly improved prediction accuracy. However, there is a large gap between the research and practice. While many studies report over 95% accuracy, clinical adoption is still below 5%. These are the research gaps. Several research gaps emerged from our survey, but most three important ones are: first one, interpretability crisis. Models often act as a black boxes, limiting clinical trust and actionability. Second, standardization issue. Over 80% of the study come from single institutions with a highly variable protocols. And the third one, scalability challenges. The high computational demands of multimodal deep learning hinder real-world development. This is table number 4. In this table, we list the most commonly reported limitations in oncology deep learning studies. The recurring themes are interpretability issues, meaning clinicians can't always understand why the model makes a certain prediction. Second, data standardization problems, since different hospitals use different imaging or genomics protocols. And last but not the least, scalability barriers, because models that work well in research often require huge computational resources that most hospitals don't have. So basically, table 4 really reinforces the critical, you can say, research gaps we discussed earlier. To bridge these gaps, we suggest the following directions. First, unified matrix, establishing a standardized evaluation criteria with clinical feasibility in mind. Second, federated learning, enabling multi-institutional training while preserving patient privacy. Third, human AI collaboration, integrating clinical expertise with AI decision making for better adoption. And last but not the least, regularity alignment, ensuring frameworks comply with medical guidelines and data protection laws. Looking forward, we believe the next generation of AI in oncology will focus on greater emphasis on explainable AI, expansion of multi-institutional studies, and seamless integration into clinical workflows. Ultimately, AI will not replace clinician, but will become an, you can say, indispensable collaborator in cancer diagnosis and prognosis. So, to conclude, deep learning has demonstrated remarkable potential in oncology. Multimodal integration provides more accurate and holistic cancer diagnosis. Yet, critical challenges, particularly interpretability, standardization, and scalability, must be overcome before this model see widespread clinical adoption. With this, I conclude my presentation. Thank you for your attention. I would be happy to take any questions or discuss your perspectives.
Thank you, ma'am, for a very insightful presentation.
Thank you,
And
ma'am.
like you have compared the diagnostic and prognostic model in oncology.
Correct.
So, like in your comparison when you were doing, so how did these models differ in terms of the data requirements?
So basically, first of all, this is a medical domain. So data is very less. And also, if any hospitals have such kind of data due to privacy concerns, they don't provide it. And also, there are two different perspectives. One, the clinical do research, the radiologist is a different. And when we apply AI, that is deep learning on that same. So very few research has been done by combining these three data modalities together. For an example, if we go with the first one, medical imaging, so few models like CNNs and all that can perform better because we have, trained data and the labels on the same. But we go for the heterogeneous, then other models perform best because we are not working on any image. You can say CT scan or PET scan, we are not working on it, but we are working on the biopsies, right? So, but if we combine these three data together, because to identify the cancer, which is like very difficult using any one image, one cannot predict using CT scan only or PET scan only. You have to do the biopsies. But the research are focusing only one data models only. So if we combine three of them and apply the deep learning, and only CNN is not enough, so we have to also integrate CNN with the transformers and attention mechanism, which is a recent development in the deep learning. Then yes, it will become powerful decision making.
Thank you, ma'am.
Yeah, thank you so much, ma'am.
Yeah. Thank you.
Yeah.
Thank you, Nushat, for your presentation. Now I'd like to invite the next presenter. Next we have Stefano Palomino, and he's going to present the paper titled Fostering Resilience Strategies Through Smart Manufacturing, Innovation, and Circularity in Agro-Food Supply Chain. Dear presenter, are you available in the meeting?
Yeah, I'm here.
Yeah, you may please proceed with the presentation.
So, good morning. I think it's daytime over there. From my part of the world, it's nighttime. So, I'm Stefano Palomino, and today I will present our work. It's called Fostering Resilience Strategies Through Smart Manufacturing, Innovation, and Circularity in Agri-Food Supply Chain. As you can see in the slides, it's my partner, Rodrigo Conde Ramirez, and also it's my colleague from Universidad Peruana de Ciencias Aplicadas, UPC in Peru. Okay, so let's see. So in the first part, we're going to talk about the work or study addresses the critical challenge of building sustainable and robust agri-food systems in the face of disruptions like climate change and geopolitical conflicts. We investigate four key strategic dimensions: resilience, smart manufacturing, innovation, and circularity. That is also part of our keywords. So the core objective was to prioritize these dimensions to provide a clear decision-making framework for managers and policymakers uh, using the best work method. So in the last slides, we will show the key finding and the most important dimension and also the most critical enablers that we're going to talk about. And next slide. Okay, so literature review. Um, so what do we focus on these four specific dimensions? Our literature review confirmed that they are most prominent and interconnected strategies for modernizing agri-food supply chains. Resilience, uh, for example, is the most fundamental capacity to respond any shocks in today's environments. Also, smart manufacturing and innovations represent the technological engines, tools like AI, IoT, and blockchain that can enable efficiency, visibility, and adaptability. Um, we have also the dimension of circularity that embodies the essential goal of a long-term environmental sustainability. And well, the interplay between these dimensions is, of course, complex. For instance, we have the technology from the part of smart manufacturing that can enable both resilience, like via real-time monitoring, and circularity, like via waste tracking. So our goal was to untangle this complexity and determine the primary strategic focus. Okay, so I want to talk about also the best work method and that also well known called drivers. So to move like from the abstract concepts to a measurable criteria, we broke down each dimension to a specific and actionable enabler. Identify, of course, through a systematic review of a recent literature review. That it's research from 2022 to 2025. For example, we have resilience that was evaluated through enablers like recovery agility and strategic resilience or strategic resilience efficacy. Also, circularity, we have sustainable sourcing and also stakeholder collaboration. In smart manufacturing, we have also the technology complexity and the employee acceptance. Innovation, we have the digital maturity and technology infrastructure. So these enablers provided the concrete criteria that our experts later evaluated, ensuring that our study was grounded in practical reality and not just theoretical concepts. So we have the results. And so we employed also mentioned the best work method due to efficiency and ability to produce highly consistent results compared to other methods like AHP, FUSI. And the process involved four key steps with our panel of the industry experts. Uh, first, there is the eight experts that we surveyed they select the best or the most important enabler and the worst and least important dimension. Then they rated the preferences of best or the rated the preference of the best over all the other dimensions, and then they rated all other dimensions over the worst. In general, when we survived, and we also used complex calculation that the best work method provide us, the results um, are like this, and like you can see the table. Um, like you can see that the most important dimension is resilience because it has a big weight on the group. And maybe you can see better in this graphic the results for each enabler because each expert that we surveyed, they respond with the most which they prefer or which they consider the most important first dimension and then enabler. So you can see first the most important dimension, and then here in this graphic you can see the most important enabler, that is the strategic resilience efficacy, and the second is recovery agility. So in conclusions, we know that resilience is our top priority, and we consider that these capabilities are critical for handling any disruptions. And on our work, I mean, the main theoretical contribution is a structured decision-making framework that prioritize a complex strategic dimensions. And for future research, we consider that we can integrate other dimensions like Industry 5.0, or we can also maybe try on different contexts. Thank you. And now I'm happy to take your questions.
Hello.
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 Oh, yeah, I can hear you.
Am I audible to you?
Yes, yes. Yeah, ma'am.
Okay. So, you found resilience is the top priority and then rapid recovery capabilities are critical for handling disruptions. So, how will you take care of other things which were ranked low in your system?
I mean, yeah, it's our top priority, but it doesn't mean that that other dimension we're gonna like get rid of it. It's also applicable, and we also try to prioritize, like I also said, because we can like wait, I'm not right. Okay, so we can prioritize first resilience, then innovation, and then smart manufacturing, and for last circularity. I don't know if that was clear.
Like now, as the globe is talking about circular economy, all right, but if you go on your previous slide, you will find you have circular economy, which parameters are ranked highest?
This light?
Yeah. No, go to the previous slide.
Okay, this one.
Yeah. So circularity, if you see, your group weight was 1.101. All right. So the enablers were this. So which is the highest? What is your C2?
Yeah, my C2 is not shown
Okay.
in the presentation right now, but Let me see.
Because here C2 is not visible. Can you see? But if you go to your previous weight slide, you find that C2 is having a higher rank. And your result, it is not visible. So is there, like if you see here, C2's rank is 15
Yeah.
and C1 is 10. So you have in there your result summaries. Is that result summary not full, which you have shown here? Is it a part graph of your result?
Okay, so what I understand is that you say that C2 is has a big weight than C1. Is like what you're saying?
Yeah, I want to say that I'm saying that only, but if you go to the next slide, your other parameters. So you've restricted this graph because it is still C3 only. That means till you rank 14. And what about the remaining? So have you not taken the full results graph here?
No, yeah. I'm simplified. Well, this graphic is simplified because, of course, we take all the results in this table and we graphic and this representation, and we also filter the most important. In this case, we consider the um, until the 11th, most important. But we can also show all the neighbors, and you can see like where is the first and what is the last.
Okay. And can you suggest one strategy for improving your teamwork and one for sustainable sourcing?
Uh, One for proving what? I'm sorry, what?
One strategy, like your teamwork is ranked 13. So to improve teamwork, can you give one recommendation? And to improve your sustainable sourcing, can you give one recommendation?
Yeah. So teamwork is also like a very weird enabler. It's part of dimension, and my suggestion is that considering the context of innovations, we when we talk about teamwork, we talk about ideas that contribute each colleague in the enterprises. So my suggestion to improve the teamwork in the context of innovation is that the enterprise have liberal ideas so that colleagues or any worker can express their self. And for the part of sustainable sourcing, um, is part of the dimension of circularity. Of course, any company can't like have a contract with a provider that has a lower cost, lower cost, but it doesn't mean that his products are sustainable. So to improve any supply chain and to make sustainable in a long term, we try that each company contacts at least a provider that has a certified sustainable sourcing. So it's in general my comment.
All right. All right. Thank you.
Thank you.
Oh, sorry, my apologies. Next, we have Om Roy for presenting the paper title Understanding and Mitigating Bias in Artificial Intelligence Systems and Ontological Perspective. Om, are you there?
Yep.
Yes, you may please proceed with your presentation.
So, hello, everyone. Good morning. I am Omar from Jarusud, and I am. Uh, uh, Hello, I am audible.
Yes, you are. Yes, Om, you are audible. You may please proceed. Okay, I think so. Om is facing a technical issue from his side. So till then, we'll continue with the next presenter. Next, we have Tejaswini Selam, and she's going to present the paper title Using ChatGPT for Sustainable Development Education Potentials, Risk, and Governance Needs. Tejaswini, are you there?
Yes, sir. Am I audible?
Yes, you may please proceed. Yes, you are.
Is my screen is visible, sir?
Yes, please make it full screen and you may please proceed.
Yeah, sure, sir. Yeah. Good morning, everyone. And today I'm going to present about using ChatGPT for sustainable development education and their potentials, risks, and governance needs. This is the agenda, and these are the points to be discussed in the presentation. Coming to the research focus, this research focuses on examining how ChatGPT and other language models are contributing to sustainable development education. In particular, I look at the relationship with two sustainable goals, mainly SDG 4, quality education, and SDG 12, responsible consumption and production. The three questions which guided this research are the pedagogical potentials and ethical risks of ChatGPT, and the alignment with SDG and SDG 4 and SDG 12, and the governance risks for responsible AI use. And the emerging themes included in this research are educational impact of AI, where ChatGPT shows potential for personalized learning, blended teaching, and models, and broader access to knowledge. The second theme is that stakeholder ethics and governance perspectives. This discuss about the issues like bias, equity gaps, and the digital divide become very significant. The third is that integrity challenges in AI assisted teaching, particularly concerns over plagiarism, over reliance on machines, and the risk of reducing students' critical thinking skills. The analysis of literature and what are the key gaps identified are mostly technological promise and limited exploration of environmental footprint. Coming to the main points covered in this research chart, ChatGPT and LLM are changing education with different ways of technology, but there are challenges exist like academic integrity issues like plagiarism, misinformation, bias, and inequality due to digital divide. And also the study connects mainly SDG 4 and 12, and the major gap is that very few studies consider AI environmental costs, such as energy use and carbon emissions. The aim is to identify the risks and potentials in using ChatGPT for education. Coming to the theoretical background, mainly it covers the three concepts like the sustainable development goals discussed earlier, and the ethical governance in AI, and the critical digital pedagogy like what are the potentials like teaching and learning advantages that ChatGPT or other LLMs can bring into the education. Coming to the literature review, these are the literature review I structured and the findings into a table with enabler, the function, and the title of the related papers with the from 2023 to 2025. These are the relevant papers. And the methodology the approach I have taken is that systematic literature review guided by Prisma framework, and also it ensured the rigor, transparency, and replicability. It combined the systematic research and thematic analysis. The data source I have taken from international journals, and also the terms used like ChatGPT, generative AI. It is a result of 135 papers, and after screening and eligibility checks, it have included of 59 articles. Coming to the results and discussion, these are the cluster themes which I have taken into consideration, and these are the key insights from those clusters. Like, for example, some of those are AI-driven education and learning impact, and what are the key insights that are it improves personalization and learning tasks, Whereas coming to policy and practice, it included of policy makers urged to balance innovation with social inclusion. And these are some of the implementations from my research that we need to set clear rules on ethical use and also equity and digital inclusion, AI literacy and training, some of the policies and frameworks to balance the innovation and caution, and also some encourage stakeholder collaboration. And the conclusion and future work is we need to balance both the opportunity and risk. Like ChatGPT, it enables us for the personalization, but also the risk coming from using the ChatGPT need to be balanced. And also the governance and essential, like to align with the sustainable development goals discussed. And here are the limitations are that it only covers the recent papers, and the future research indicates that long-term studies on AI literacy and pedagogy, and also develop learner-centered frameworks for responsible AI use. And these are the references I have taken from my research, and that's it. Thank you. I'm open for Q&A.
Thank you, Tejaswini.
Yes, ma'am.
You have done a literature systematic review.
Yes, ma'am.
Yeah, and for AI, these articles of ChatGPT, you have used Scopus as the database.
Yes, yes, ma'am.
So, what was the reason behind using Scopus? Because we know that Web of Science is a database which have more articles from such fields. So, why did you use Scopus?
It's like, ma'am, it's not only because we have used the Scopus index, it gives the relevant test papers or else which are for my studies which are more relevant, they have used it. So I have used the Scopus index.
Okay. And like whatever recommendations you have given, what are your
Yes, ma'am.
major, like, can you suggest something like ChatGPT you cannot do away with now
Yes, ma'am.
in education sector, especially if you are talking about.
Yes,
So,
ma'am.
what is your suggestion so that these AI models are included in teaching field?
Yes, ma'am. So coming for that, we cannot say that we don't use ChatGPT in our daily lives, but we need to use it. So balancing both the opportunity we have in ChatGPT and minimizing the risk. Like we don't fully use the ChatGPT content for teaching, but also our learning way of teaching to be included with the ChatGPT. Balancing of both of them could give a better result.
Okay. And how do you ensure that you are facilitating an ethical use of such large language models by the students?
By, if we can say, the fairness and ethical use in the technology, we can say that, ma'am, and also like guidelines and accountability in using that may have an ethical concern.
Okay, so according to you, what should be the, like we go for the similarity index, what should be the AI percentage when you are taking, like if as a teacher you are giving any assignments, so what percentage of AI should be taken?
I would say it would be less than 30%, so that it could be more human generated, which could include our thoughts and our way of learning.
Okay, because now if you see the recent studies and if you see the latest Turnitin software, it has started detecting AI.
Yes, ma'am.
Right. And now, since the industry and everybody is talking about integration of AI, you'll find in Turnitin that below 20%. So 20% is the
Yes,
standard which they have started adopting because you cannot do away with it.
yes, ma'am.
So that is around 20% which you have, because less than 20%, if you go to Turnitin, it is not showing.
Yes, ma'am.
That is the standard which you have to take. And as your research points out, an ethical use is very important, because as a
Yes,
faculty also you need to use AI so that you remain in relevance with the students, because the generation which is coming now is more friendly and more dependent
yes,
on
ma'am.
such large language models.
Yes.
And I would suggest that since you have used only a very small period, 23 to 25. If you can expand that period and you can include more databases like Web of Science and all, you will may get more relevant papers and the keywords which you used while searching.
Okay, ma'am.
That if you improve, I think you will get more relevant results and more valid
Yes.
findings.
Sure, ma'am.
Okay. That's all from my side.
Yeah, thank you, ma'am.
Thank you, Tejaswani, for your wonderful presentation. Now I'd like to invite again. Om, are you ready for the presentation? Om, are you ready for the presentation? Okay, I think so. He lost the connection with us. Okay, once last announcement for the absent participants. Sarika Pabalkar. Is there anyone who's going to present the paper title Generative Advertising Network for a Medical Image Augmentation Comprehensive Study? Is there anyone? Okay, so I think so we have completed our presentations here. As Om is not able to present the paper and Sarika is not available in this meeting, we are concluding this session. So
Hello. Am I audible?
yes, Om, you are audible.
Okay. So
Are you ready?
can I proceed? Yeah. So good morning, colleagues. I'm Omroy, and I'm uh, uh, giving uh,
Hello? Om, are you there? Om, are you there? We'll wait for one more minute if you can join us again. Om, I suggest you should, if you are listening me, you can you should share your recorded presentation to us on our support email ID, right? That will not going to affect in your publication process if you want so. Meanwhile, I will suggest I should conclude this session as we are running out of the time as we have back-to-back sessions through the day. Okay, so I sincerely thank all the authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough to all the participants who are presenting here. We, on behalf of the whole team, thank you for your support during this fourth version and all the previous three versions of the conference. We will be happy to have you all in the next fifth version of this in 2026. Further, all the presenters will be getting their digital certificates through email within 2 to 3 working days. Further, the publication will be live within 7 to 8 months. Kindly cooperate with the team ISBM 2025. Further, I also thank our session chair. Further, I also thank our session chair for chairing the session. And ma'am, there is one token of appreciation to be a chair on behalf of Global Knowledge Research Foundation and Team ISBM 2025.
Thank you, Harsh, and thank you, Team ISBN.
Thank you, ma'am. Okay, so now at the end, I request you all to turn on your camera so we can capture a quick snapshot to make this conference more memorable. I request others, if it is possible, you may please turn on your cameras. Yeah. Thanks a lot to everyone. Thank you, ma'am, once again for sharing the session. And thank you
Thank
all the
you.
participants for their excellent presentations during the session.
Yeah, thank you, Harsh, and thanks to all participants for wonderful presentations.
Thank you, ma'am. Thank you.
Thank you.
Have a good day to all.
Thank you. Thank you.